Hello, everyone, and welcome back. Welcome to Unit 6 of AAF, which is going to be our study of rational functions. So, talk to me. What is a rational function? What does it mean for something to be rational? Think about what you know or what some context clues are that you can think about. What's a ratio? Right? Oh, a ratio. You've done this before. You've done this in geometry. You've done this in algebra 1, right? A ratio is when you are comparing two numbers or two values or two integers, right? Like it's a 1-to-2 ratio. It's a 7-to-3 ratio. They can be expressed in different ways, right? A common way that we express them is as a fraction, right? A ratio. So, rational functions, well, we're building on things that we've done in the past, is a ratio of two polynomials. Whoa! What we've done, what we've been working on mastering is not, it's still there, right? So what you've learned about polynomials, clearly not how to spell them, you need it. What you've learned about quadratics, you need it, right? You needed that when you were doing polynomials. We're building here, right? Like we're really getting into like how do all of these things connect? Things you knew about functions don't go away. Characteristics don't go away. So really at this point, you're starting to see how all of the things that we've studied connect, which is amazing. It's one of my favorite parts about this class. So that is what we're going to be studying throughout Unit 6. Unit 6, your textbook goes very nicely along with Unit 6. Okay, it's chapter 7, which starts on page 323. So there might be times where some of the extra practice is in the textbook, or we might have a homework assignment or practice that's coming from the textbook. So that's going to be a really awesome resource. Or, hey, it's a textbook. If you're having trouble with a concept or you want to read more about a concept, it's an awesome textbook to go in and kind of read some of the examples and take a look at those. So strongly suggest that. Just looking at my spelling of polynomials. Wow, let's keep it moving. So some prerequisite knowledge, and this is not all inclusive, right? Like there are some other skills that you're going to need in order to successfully move forward as we go through this unit that might come from earlier math classes that I'm not going to list here. Okay, I'm just thinking about your prerequisite skills and knowledge that you have from AAF is where I'm going, okay? So can you multiply two polynomials? Whether it's two binomials or a trinomial and a binomial or right? So what do I mean by that? A binomial, two terms. Can I multiply x plus 4 times x minus 7, right? Well, can I get a little crazier with this? Can I multiply x squared minus 3x minus 9 times x squared or 2x squared minus 7x plus 3, right? Sometimes you get a little bit messier. You've got three terms, but that's what I mean. Can you multiply two polynomials? Okay. And then a big one is factoring, right? And these are really key skills that we need as we're going into our study of rational functions. And there's some other things too, like being able to distinguish between things. Oh, what's the difference between an equation and an expression? How do you add fractions? How do you multiply fractions? How do you divide fractions? How do you simplify fractions? But those aren't really skills that we've talked about in AAF, so I didn't include them here. So factoring polynomials, let me finish my thought. We've learned a lot about factoring. Have common factors, our quadratic trinomials, our difference of two squares. Remember, there's no sum of squares, that would be prime. It can be factored by grouping, our sum and difference of two cubes. Okay, so those were all the factoring that we talked about. So, as we begin this unit, the first thing that we're going to be doing is using our knowledge of factoring polynomials and basic operations. What are some basic operations? Addition, subtraction, multiplication, division. With fractions, basic operations with fractions. And so remember some key things that come along with fractions To successfully simplify, so as much as possible, you want it to be in simplest form. We'll talk about what that might be. Rational expressions. Our focus is going to be on multiplying and dividing. And you might wonder why we're not starting with addition and subtraction, and that's something that we're going to be doing next. And to answer that question, when you're dealing with fractions, why might multiplying and dividing be simpler than adding and subtracting? Let's say I gave you 1/2 and 4/7. What do I need in order to add these two fractions? I need, when I'm adding or when I'm subtracting, I need a common denominator. However, if I have 1/2 times 4/7, I don't need a common denominator. Let's just multiply. What's half of 4/7? Well, not 8. 4/14, right? Or 2/7. Half of 4/7 is 2/7. Whereas when I'm adding or subtracting, I need a common denominator. So it's actually not, it's a basic operation, but it's a little bit more involved, right? And as you can imagine, when we start putting a polynomial in the numerator and denominator, we've got to do some other things. That bring in factoring, right? And so we're going to need that common denominator that we don't need for multiplication and division, right? If I told you to divide 1/2 by 4/7, well, what is a nicer way? Instead of dividing by a fraction, we can do what? I paused and hopefully you said to yourself, multiply by the reciprocal, right? I can multiply it by the reciprocal. Instead of dividing something by 1/2, I'm actually just multiplying it by 2, right? So I would end up with 7/8. 1/2 divided by 4/7 is 7/8. So our focus is going to be on multiplying and dividing. There's some key words in this objective that I want to talk about before we move on, and they are factoring polynomials. I can't emphasize enough. Factoring is so important to us. We are going to be factoring polynomials as we have for the last 2 units. Keep practicing, right? It's like riding a bike. I shouldn't use that reference because I don't know how to ride a bike yet. No, I don't know that I'm going to learn. But you got to practice, right? It's got to be part of your daily life. Factor, break things apart into smaller parts. There's so many resources, like keep using the resources and keep practicing. Repeated practice is how you get good at this, right? You're going to become more in tune with like looking for certain things because you just had more experience with it, right? It's a skill that you can build, and you got to persevere through that. So you got this. Keep working with it. And the other thing that I want to point out is this word expressions. And I feel that this has come up, and we all have gotten quite a bit of feedback about this throughout at least the last unit. But what's the difference between an expression versus an equation? An expression has no equal sign. There's nothing to solve for. Right? That's why it says factoring. You can't use the quadratic formula. The quadratic formula is for solving. An equation has an equal sign. You can be given the command solve if you have an equation, if there's an equal sign in there. Whereas an expression, all you can do with it is simplify, right? That might mean that you're breaking it apart into pieces by factoring, or that you're, I don't know, you're multiplying out, you're expanding something. But there's nothing, like you can't move something from one side to another. You're not going to be using inverse operations because there's nothing to solve for. So keep that in mind that we're dealing with rational expressions, a ratio of 2 polynomials that are an expression, and we're going to be manipulating it. Also keep in mind that what's a number you can multiply by that doesn't change anything? 1. That 1 can take any form. right? Like maybe I want to simplify something and I need to multiply it by 4 over 4, or x over x, or x plus 4 over x plus 4. You did this when you dealt with simplifying complex numbers, right? We weren't changing anything. You maybe had 3 over 2 plus I, and you multiplied both the numerator and denominator by 2 minus I. You didn't change it. You re-expressed it. And that's what we're going to be doing when we're dealing with this stuff today. Okay. It's a really long objective. Let's get started. So multiplying rational expression. So here I have two rational expressions that I'm multiplying. X squared minus 5x plus 6 over x squared plus 5x minus 6 times x squared plus 7x plus 6 over x squared minus x minus 6. Can't cancel anything. You can't cancel across addition and subtraction. I need pure multiplication to be able to cancel, because that means that you're dividing in equals 1. That's what canceling is, right? So my first step is I'm going to factor this. Then I'm going to cancel any matching factors, right? When I'm saying cancel, I almost want to put that in quotes, right? Cancel means that if you have something in the numerator and something in the denominator, it equals to 1 and you don't need to write it. It's kind of like when you just have 1x, you don't need to write the 1. Okay, and then I'm going to expand anything. And the reason for that, when I want it to be in simplest form, is that think to yourself, if you end a problem and it's 7 times 2, do you want it written as 7 times 2 or do you want it written as 14? Which one do you consider more simple? I consider this more simple, right? This would be factored form. So we're going to expand it for our final answer. So don't get cancel happy. You can't do that. No, not allowed. We're going to factor, okay? So we're going to use our knowledge of factoring here. So x squared minus 5x plus 6 is x minus 3 times x minus 2. And you can see what I did here. So as you can see, like I've got clean multiplication here. Nothing is being added or subtracted. I have a bunch of things that I'm multiplying, right? So let's see. I'm going to look for some, and remember, multiplication can happen in any order. So I'm going to look for some common factors. Okay, I see an x minus 3, and I see an x minus 3. Cool. Can't those simplify? That's just 1, right? If I multiply by x minus 3 and then divide by x minus 3, it undoes it. It's like it didn't happen. I also see an x plus 6 and an x plus 6. Okay, so when those things cancel, what am I left with? Right? Those cancel. Those cancel. I now have this, right? Because I did that last step of expanding. Can't find my pen. What color is it that I can't find it? I found it. Right, so I'm left with, here I can even stick this here. I'm going to multiply this out, and that's where I get x squared plus 1x minus 2x minus x minus 2 over x squared plus x minus 2. That is my final answer. There's nothing else I can do. Like that is, I have multiplied and simplified this rational expression. What's an interesting thing, sorry, I'm going to go back to here. What would be out of my domain? Like, what would I have to kick out of my domain? I want you to think about it. I'm getting a little bit ahead of myself. What can we not divide by? What's illegal to divide by? We did this. This goes all the way back to Unit 1, I think it was. You can't divide by 0. We're going to kick something out of our domain. All right? My denominator can't be equal to 0. So let's see how this all ties together. Math is beautiful. X minus 1 times x plus 2 equals 0. So x minus 1 equals 0. X cannot equal to 1. X plus 2 equals 0. X cannot equal to negative 2. Right? So if I asked you to find the domain, if this became an equation and we had to graph it eventually, I'm kicking some stuff out of my domain. X cannot equal to negative 2, and x cannot equal to 1. Again, getting a little bit ahead of myself here, but if I was asked to graph this might be my first function that I've really dealt with, right? Other than piecewise functions, which are pieces of different types of functions, or different functions. My first function that is not continuous. Crazy. Exciting. Okay. I got a little ahead of myself. That stuff will come up more. So just focus on the multiplying and dividing and simplifying. Okay. So here we're dividing. Just like we said, instead of dividing by a fraction, multiply by the reciprocal. So what I mean by leave it, change it, flip it. Leave the first one. Change it, change the sign, flip the second. All right, that's what we did when I gave you that example of, I can't even remember it, but I think it was 4/7 divided by 1/2. I left the first one, I changed the sign, and then I, flipped the second one, right? So I'm going to, I thought I animated it in, sorry. I don't know what's going on. Leave the first one. Change the sign, and then flip the second one. So x squared plus 2xy plus y squared over x squared minus xy plus y squared. And now it just looks like the problem before. So my next thing that I want to do is I want to go ahead and factor everything. Okay, so here I need to recognize that that right there is sum of two cubes. So you've got x plus y times x squared minus xy plus y squared. Oh, did you see something? Over, I'm going to leave that, right? You know what? I'll even write it out 3 times so that we can kind of see what happens. Times, this definitely factors. Isn't that just x plus y squared? So I'll write it out twice so we can see what happens. And then I'm going to leave that. That doesn't factor. But I see something exciting. Okay, let's see what's common. I've got an x plus y and an x plus y. I've got another x plus y and another x plus y. I've got another x plus y and another x plus y. And then I've got one more thing. I've got this. Oh, that's a terrible color. A terrible highlighting color. It's a pretty color. Oh my gosh. Bam, 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 bam. What does this equal? 1. Canceling means it equals to 1, not 0, right? When everything cancels out, it's 1. Crazy. This whole division problem was just 1. How fun was that? I would say you guys should try this. I would pause the video if I were in your seat. Or maybe you're not sitting. And try this. Okay, so hopefully you've tried it. Let's see what happens. Okay, so here's what I did. I factored this. Right, so x squared minus 4 is this. That's difference of squares. Doesn't that look pretty similar? These two look kind of like this, but I can't cancel it. I've got all multiplication going on, but this isn't right. This is a negative x and a positive 2. So what can I do? Well, there's a few ways I could approach this right now. All right, those look like I should be able to get there. So what I'm going to do is I'm going to factor out a -1 to write 2 minus x as -1 times x minus 2, right? So if I take 2 minus x, I can factor out a -1, and this becomes -2 plus x. I can also rearrange those, so I get -1 times x minus 2. And then I've got it, right? So I can cancel them, but I need to remember that I now have a negative. It doesn't matter where that negative goes. I can stick it down here, over here, up here. It doesn't matter because it's all multiplication that's happening, right? So I'm okay. If you don't want this here and you want to put it here, right? And then know that these signs change and it cancels. That's fine. regardless, you're going to have a negative in there. It doesn't matter where that negative goes. So I'm left with, oh, sorry, I lost my train of thought. So the other piece that happened is this 30 and this 5, this 30 and this 6, 30 and 6, I'm pointing to the wrong things, are 5. So that's where this negative 5 came from, right? So I didn't need that. I could add a step in here and say, well, it's 30 times x plus 2 over negative 6. These right here, where that negative 5 comes from, times x plus 2, so that's negative 5x minus 10 would be what my answer is, right? So this multiplication problem is equal to this. Show your process that it is there for us to follow so that we can see what happens. It also allows you a way to more effectively check your own work and to see, where did something go wrong? Where could I have made this better? Okay. Try this one if you haven't tried one on your own. You can see you might need to do some osmosis here. Sorry, too fast. Okay, let's see. So I'm going to go ahead and do the same thing I did on the last one. Let's change this to put a negative 1. That becomes negative. That becomes positive. Okay, so I have x plus 5 in the numerator, negative 1 times x minus 5 in the denominator, times, what's here, x minus 5 times x plus 1 all over x squared. So here's what I think I can do. These will cancel, and this is what I'm going to be left with, right? I can't do anything else with that. I've got x plus 5 times x plus 1 all over negative x squared. I don't see anything else I can do with that. So I'm going to go ahead and expand it to make it as simple to get my final answer. X squared plus 6x plus 5 all over x squared, negative x squared. Let's say that negative for you was in the numerator, right? Maybe I just have it out front. Maybe it's negative x squared plus 6x plus 5 over x squared, right? Like you have it out front of the whole thing. Maybe you have it in the numerator and it's negative x squared minus 6x minus 5 divided by, nope, that would now be positive. Right? Maybe that's what you have. Any of these are fine. You just need to be careful if this negative goes to the numerator, it needs to go to everything in the numerator. It has to, whichever part it goes to the entire thing. Okay, so just be careful with it. I would probably go with either this option or this option. Okay, for real, if you haven't tried any, these two are for you. That last one looks real fun. Okay, so I'm going to go ahead and change this to multiplication, right? So this is the same thing as x cubed plus 8. Ooh, that's sum of cubes. X minus 2 times x squared minus 4x plus 4 over x squared minus 2x plus 4. Okay, my numerator. X plus 2 times x squared. That's a minus. Minus 2x. See how if you can effectively factor, you want to get quick with it so that it doesn't stall you when you're trying to do these problems, right? Divided by x minus 2 times, let's factor that, x minus 2 times x minus 2 over x squared minus 2x plus 4. Let's see, what cancels now? I've got this and this. Common factor. When I divide it, it's going to equal to 1, so bye. I've got, not yellow, I want green. This and this. When I divide, it's going to cancel. Solidly used the same color there. Bye. Okay, so I'm not left with too many things. I'm left with, in my numerator, I'm left with x plus 2 times x minus 2, which is difference of squares, and I know that those are conjugate, so I've got x squared minus 4 as my answer. Okay, let's check out this last one. I'm gonna deal with this right here and change this to multiplication. So, and then I'll deal with the factoring. Xy minus y squared over x squared minus x times x squared plus xy over xy minus y. So start thinking about your factoring if you haven't already. And then I'm going to flip this. X squared minus xy over xy plus y squared. Okay, is there anything right here that I can factor? No. I'm sorry, some cancel? No. I'm going to go up here and keep writing. So here I actually have a common factor, don't I? I can factor out a y. So I'll go ahead and do that. I've got y times x minus y. In the denominator, I should be writing this down. No, it wouldn't work. I can factor out an x, right? And then I've got x minus 1. Okay, let's keep going with that. Here I can factor out an x. And then I've got x plus y. And then the denominator I can factor out a y. And I've got 1 minus y. Did you guys, oh no, I didn't. No, I don't. I have an x minus y, don't I? Oh, I could have canceled these. Nobody told me that. It's okay. I'll just go with this. Now that I've written it. X times, it won't change my answer. 1 minus, nope, that's going to be an x minus y. Right? Where am I? I'm over here. I factor out a y, I factor out an x, and then the denominator here, I'm going to factor out a y, and I'm going to be left with x plus y. Okay, what cancels after my mess of what I just did? I've got an x minus y. Here, I've got this y and this y. And then this x minus y and this x minus y. I'll get rid of those. And then I've got an x and an x. I've got an x plus y and an x plus y. And I think that's all. Right? So those all go away. That cancels with that. That cancels with that. The blues cancel and the yellows cancel. So in the numerator, I've got x times x minus y. And then in the denominator, I have a y times x minus 1. Okay? So I actually have x squared minus xy divided by xy minus y would be what I end with. Right? So factoring by grouping, factoring trinomials, sum and difference of cubes, difference of squares, you kind of see how that plays into all of this. So if there are questions that you have, what I would suggest you do is write them in your notes so you don't forget them when you get to class. Okay? I think that would be a really great thing to do. So that concludes this introduction, right? So you learned what a rational function is. You see, hopefully, how some of the things that we've studied apply and come in to this. And we've done simplifying, not solving, simplifying rational expressions, not equations, expressions, with a focus on just multiplying and dividing. When we see you next in our next session, our next lesson, we will be focusing together on adding and subtracting. So keep in mind some of the things that you know about how you add and subtract fractions, which will also be an important part when we're dealing with rational expressions. So thanks for watching, and we will see you in our next live class.